All right, let's go ahead and try to graph these here. I got it printed, so here we go. The first one, try this again. Go down to the y-intercept, -3. We rise 2, we run 1. If I count correctly, there we go. And then we can continue that. All right. Did I make a mistake again? Jordan's laughing at it.
I'm just amusing myself with my thoughts.
Oh, okay. All right, this one right here. If you want to use x and y intercepts, how many know how to use the intercepts to graph?
You set it to 0. No,
Okay, that's how we'll do systems of 3 variable equations, is we'll use the intercepts. So you have to be able to set x equals 0, so plug 0 in for x and solve for y, so that would y equals 3, so you'd have the ordered pair 0, 3. So we go here, and then plug 0 in for y and solve for x, you'd have the ordered pair 3, 0. Okay, so that would be there. And then you can see that you'd go down 3 and over 3, so you have a slope of -1. And so when you're graphing these, I'm fine when you're trying to find the solution. You don't have to do full graphs. You can just do mini-me graphs to find this point. That's the point of doing it. Get the point? All right, 2, 1. Make sure you list the point there. Circle your solution. There we got it. We could test it if we put 2 in. 2 plus 1 is 3. So we're good. And we put 1 in for y, 2 in for x. 2 times 2 is 4, minus 3 is 1. We're good. It makes 2 true statements, so we're good to go. Okay, how many have an answer for 6? One person? Who's completed 6?
I have a graph, I just don't like it.
Yeah.
You don't have the solution?
Yes.
Uh-oh. What's wrong with 6? Why is it so tough?
Fractions.
You get a fraction?
Yeah.
But like,
Okay.
yeah.
So if you change this slope-intercept form up here, I'm going to work upwards, but I subtract x from both sides, so I get 2y is equal to -x plus 13, right? Then we divide by, so that's a 13, not a b. Okay, we divide by 2. So this is a -1/2 x. So y equals -1/2 x plus 13 halves. It's not bad having a slope. That's a fraction. The 13 halves is kind of bothersome.
It's quite bothersome.
13 halves is what?
6.5.
6.5. So we go up here to the y-intercept of 6.5. We go down 1 over 2. Down 1 over 2. So we can still do it. It just means that it's a little tougher. This is one of those problems you'd probably want to use one of our algebraic ways of finding the solution for it. Okay, so that would be using the black ink there for that one. And here, moving this around, y equals -x plus 7. Go up to 7, go down 1 over 1. So it looks like it's going to intersect right there. So it looks like right there, and you definitely want to test that one. 1, 6, especially since you had that fraction in there. So if you test 1 and 6, if I put 1 in here, and 6 for y, 1 plus 12 is 13, that works there. And 1 in here, 7 minus 1 is 6. We're good. All right, so test it out there. All right, any questions?
No questions, sir.
Okay, good. Everyone rate themselves 1 to 5. Okay, that's good. Now we have these.
Oh, gross.
Oh, yeah. There we go. Number 10. I want you to tell your neighbor everything you know about absolute value. What do we know about absolute value? Someone else. Not that I don't. Hold on. We'll go with this. Let me do this. This is great. There we go. Number 18. Who's 18? Yes, Sammy, what do you know about absolute value?
Absolute value makes a V shape, and if the slope is positive, it'll face upward. If the slope is negative,
It's really good. Yeah, when we're talking about absolute value equations in the form of y equals the absolute value of x, it is a V shape. However, are we talking about a xy absolute value situation? Now, in this case, note the difference there. Okay, we're not talking an xy. We're just talking a single variable. So it's a bit different. But good job, Sammy. That's very true. How many said something like that about the V shape? That's great. That's exactly what I would expect you to remember from absolute value. What do we know about what the value of an absolute value is? Yes, Cody?
It's positive.
Okay. Jordan, what else?
It represents the distance of an integer from 0.
Good. It's positive. It represents the distance of an integer from 0. So if I think of this equation or this inequality as y equals the absolute value of y equals 3, let's think of it like that for a minute. What are the two values that are 3 units from 0? Yeah, and Newell.
3 and negative 3.
Why am I having Chrissa? Thank you. Right?
Claudia.
No. Claudia. You know what happened is this isn't an excuse, but let me give you the excuse. My last driver's ed class, I told you about this girl, that I called her Claudia all class, and her name's Chrissa. And now I'm stuck on the name Chrissa. It's Claudia. Sorry, Claudia. Okay, but it is 3 and negative 3. So we have 3 and we have negative 3. Okay, this is our positive case. This is our negative case. Now note that it's not an equal sign. It's actually this symbol. And when we do a negative case, what happens to our sign? It flips. So rather than less than or equal to, we should have greater than or equal to. Okay, so those are two of the things we're going to have to graph. Okay, I want everyone to graph just this one on your grid right now. The y is less than or equal to 3. So remember, if it's a y equation, it only crosses which axis? The y-axis. Now we start getting inequality symbols, we've got to start worried about different types of lines. All of these symbols up here, whether it's equal to, less than or equal to, or greater than or equal to, what type of line are those?
Solid.
Good, those are solid lines. If it's a not equal to, or a less than, or a greater than, it doesn't have any of the equal to piece, it is? Dashed. Okay, so this is a solid line that we're graphing right now, right? So we've got our solid line crossing the y-axis at 3. I've got it there, and I only wanted you graphing that one because I want to point out how we test which side we graph or we shade on. We can always put 0 in for y. If I put 0 in for y, is 0 less than 3?
Yeah.
Yes, it's true. That means we have to shade over 0, which means we're shading downward. And I'm just going to shade the bottom part of the arrow. That's all I shade. Okay, that I just kind of fill in that bottom part. I'll show you why here in a minute. Some people like to shade everything. I'm just filling in the bottom part because I'm shading down. Okay, y is greater than negative 3. So I go down to negative 3, greater than or equal to, excuse me. Draw our line. We test 0. When I put 0 in, is 0 greater than or equal to negative 3?
Yes, sir.
It is greater than negative 3, so we have to shade towards 0, which means we are shading upward. Okay? Shading upward. All right, so we finished one inequality. We now have another inequality. This one right here, and we want to think of it like this. X equaling 2. So go ahead and list your positive and negative cases out. So positive case. Claudia, you got a positive case for me?
2.
2. And so x, you know what symbol?
Less than or equal to.
Good job. Less than or equal to. Okay, a negative case for me. Someone that has it. Nick?
0 is, or x is less greater than or equal to -2.
Good. So we flip the sign on the negative case and we go negative. Okay? So we put our 2 on. Now last period when I did this, I really messed up this problem. So I made this a 3. And that frustrated every person in class because they didn't speak up when I made a mistake. They just assume I'm always right, which is kind of flattering, but not always right. Just saying. Okay. So 2, if I put 0 in here, is 0 less than 2? Yep. So we got to shade towards 0. So I'm shading that direction. The evil twin of one direction. Okay. And -2, is 0 greater than -2?
Yes.
Yeah, so I'm testing this point again, right? So we shade toward that point. And so when we're done and we have all these arrows shaded, you're looking at the arrows. Where is the overlapping region? I want you to color in the overlapping region on your paper right now. Okay, is it here? No, it's open. Here? Well, these overlap, but we have to have 4 overlaps. So technically, this would be your shading for the 2 vertical lines. 2 horizontal lines would shade right here. The overlap between them is this part right here. Okay, so that's the piece that we need darkened in. Any point in that portion is a solution to both of these inequalities. Questions there? Cody?
So because you only plug in one variable for those equations, how would you do if it was like 1, 1? Because that's a point in there. But how would you just plug 1
So
in
you,
y?
yeah. So if you picked a coordinate, say like 1, 1, right there, which we can't see when but if you wanted a point that's in there is 1, 1, we could put 1 in for y. 1 is less than or equal to 3, and then 1 in for x. 1 is less than or equal to 2.
Oh, okay. I was thinking like
Yeah.
to plug them both in.
Yeah. Yeah. Since you'd only plug in the one that goes with that equation. Yep. All right. Any other questions? All right. While I hand out your assignment, I want you to complete number 11 with your groupie. All right. We'll graph this one. This one is a dashed line. Right? That one is dashed. Okay, so we go up to 2, rise 3, run 1, so slope is 3 over 1. All right, if we tested 0, 0, if I put 0 in for y and 0 in for x, 3 times 0 is 0, 0 plus 2 is 2, and 0 is 0 greater than 2. No, so we cannot shade over 0, 0. The other way to do it is what we talked about earlier this year, right, where we talked about the y-axis. Have we done that in here?
I think so.
Where we said if it's greater than, we shade, there's all these positives up here on the y-axis and all these negatives. We want to shade the greater part of the y-axis, which is the positive side of it. So we shade up this way. Okay? So we're shading on that side of the y-axis. Now some of you will want to shade, some of you will be fine with just doing the arrows until you get the other line on there. Okay, I started shading, but this one will go in pencil. Okay, it's a solid line. And it's positive 1, down 2, over 1. That's our slope. So going down and then over until you run out of room. And then you can continue the pattern upward here. All right. make it a solid line this time. If I test 0, 0, 0 is less than -2 times 0 plus 1. So in this case, that's 1. Is 0 less than or equal to 1?
Yes.
Yes, so we shade towards 0, 0. Or if you want to think of the symbol, it's a less than symbol, so you shade the lesser part of the y-axis, which is down here. So notice arrow, arrow, shaded towards each other right here. This is your overlapping region. Okay, for those of you who are like, well, I want to see all the graph, well then shade everything on this side of that line and everything on this side of this line, and the part where the two overlap is your solution, so darken that in. So we'll darken this whole area in right here. Either way is fine with me. If you want to shade both and then darken in the overlapping because you like scribbling, go for it. Dude, it's time you get a scribble and be good with it, man. What's that?
We had to do that in Murphy's class. We had to use 2 different colors.
Really?
Oh, the pain in the butt.
That's joy, man. All right, your assignment. Let's go to the example side. You're going to do all on the example side plus number 9 on the mixed side. All on the example side except for number 9. So you cross this one out. You're going to get plenty of chances or plenty of opportunity to do story problems here in the next week or so. You'll love every minute of the story problems. Okay? But, so you're doing all on this side with the exception of number 9. I guess skip 9. But to replace that number 9, we have to do number 9 on the mixed side. Bless you. We didn't do number 9 on the mix, did we?
No, I mean like we did one similar to that.
We did one similar, yep. You're going to do number 9 on the mix, though. All right. You've done a few of these. You don't have to redo the ones we've already done in class. Just put the answers. Okay? So, and I'll assume like on 10 and 11, since we already did these, I'll assume you did them right because we already did the answers for them. We did 10, 11. What else did we do?
1 and 6.
1 and 6. Okay, so you can just write the answers next to those for 1 and 6. But 10 and 11, I'll assume you have them in your notes. Yep.
But 1, 6, 10, and 11, it says, oh wait, never mind, it says by graphing. Do we have to still put the graphs on this graph paper?
No, that's what I'm saying.
Okay.
We've already done. So. Okay, other questions? Well done. Go at it.